Hi friends, good morning. Welcome you all again this our subject mechanical engineering materials. So friends, today we are in a last topic of this our chapter called as basics of engineering materials, and we are talking about hardness testing. So in previous lecture also we have discussed what is by hardness. So simply we can say that it is a property of material which indicates the strength to resist wear, abrasion and penetration. Means these are the such material, or hard material means these material does not undergo wear, means hard material having good wear resistant. So if you take example diamond, ceramics, these are the best example of the hard materials. So as you know friends, we can measure hardness by using Brinell hardness tester as well as Rockwell hardness tester. So guys, in previous lecture we have discussed Brinell hardness tester in detail. So in today's lecture we are going to discuss how Rockwell hardness tester works. So friends, see here. In this first diagram, 3D view of Rockwell hardness tester is there. And in figure number 2 and 3, we can check the 2D view of Rockwell hardness tester. So what is my Rockwell hardness tester? So simply you can say that Rockwell hardness tester, it is an instrument which is used to measure the hardness of any material. Rockwell hardness tester, it is a instrument which is used to measure hardness of any material. So if we see figure number 2 and 3, Rockwell hardness tester consists of upper cover, front cover, key panel, then indenter, correct, then test stage, lifting rod, switch, power cable, fuse and rotary wheel. So first what we have to do, we have to start the electric supply with the help of power cable, and whether power is on or not, that we can check on the key panel. Then after that what we have to do, we have to take a specimen whose hardness we have to check, and that test specimen we have to place on test stage. Students, what we have to do, we have to take a test specimen, means any material whose hardness we have to check, and that specimen we have to place on the test stage. In figure number 3 and 2, in figure number 1 also test stage is there. We have to place that specimen on test stage. Then what do we have to do after that? We have to rotate the rotary wheel. If you rotate the rotary wheel clockwise direction, what happen? The lifting rod moves upward. Due to the rotation of rotary wheel clockwise, that lifting rod moves upward, and when lifting rod moves upward, your test specimen clamp in between indenter and test stage. As lifting rod moves upward, test specimen whose hardness we have to check, that get clamps in between indenter and test stage. After that, what happens? According to the hardness of the material, indenter moves inside the test specimen and indentation marks gives happened. Correct na? On the test specimen. Means if your material will be soft or medium hard, indenter moves inside that material. Means indentation mark will be more. If your material will be very hard, indenter moves in a less amount inside your specimen. That's why indentation mark will be less. And on the basis of indentation mark, we can check the hardness. So how we can check hardness? Let's see here. So see here again, in figure number 1 indicates or 3D of your Rockwell Hardness Tester. So see here, related to the Rockwell Hardness Tester, we can use ball indenter also and diamond cone indenter. So in previous lecture related to the Brinell Hardness Tester, guys, we have discussed related to the Brinell Hardness Tester, we can use ball indenter. And ball indenter is applicable only for the soft material. Means with the help of Brinell Hardness Tester, we can measure the hardness of only soft material. But see here, guys, related to the Rockwell Hardness Tester, we can use ball indenter also, we can use diamond cone indenter also. Means with the help of Rockwell Hardness Tester, we can measure the hardness of soft material also as well as hard material also. Keep in mind, with the help of Rockwell Hardness Tester, we can use the hardness of soft material also as well as hard material also. So if we have to check the hardness of the soft material with the help of Rockwell Hardness Tester, use ball indenter. And if we have to check the hardness of hard material, in that case use diamond cone indenter. So if we check, if you see the ball indenter, on that indenter ball is there, spherical ball is there. And if you check diamond cone indenter, diamond cone shape is there. Correct na? So clear, guys? With the help of Rockwell Hardness Tester, we can check the hardness of both material, means soft and hard. If we have to check the hardness of soft material, use ball indenter. If we have to check the hardness of hard material, use diamond cone indenter. Now see here, how you can measure the hardness. So here now two figures are there. Figure number 1 indicates we have used diamond cone indenter because cone shape is there, and figure number 2 indicates the ball indenter we have used. Means if we use diamond cone indenter to measure the hardness of hard material, it will be according to the figure number 1. If we use ball indenter to check the hardness of soft material, hardness of the soft material as according to figure number 2. So now what we have to do in both cases, means in ball indenter as well as related to the diamond cone indenter also, what we have to do? We have to apply the load on indenter. Correct na? So if we apply the load, what happens? Indenter moves that specimen. Indenter moves inside the specimen means indentation mark gets happen on the specimen. Correct na? And it will be measured according to the depth of the impression. Correct? Means simply, if we apply the load on the indenter moves inside the material, and what we have to do, we have to check the depth, how much amount of indenter moves inside the material, and in that proportion we can check the hardness. So if material will be soft, indenter moves more inside the specimen, means depth will be more. If material will be hard, indenter moves less inside the specimen, means depth will be less. So according to the depth or indentation mark, we can check the hardness. So here, where P is the applied load, it is indicated by the blue arrow in both figures, and H is equal to depth of impression. Means we have to apply the load P on the indenter. According to that, H means depth of impression will be generates on the specimen. That H we have to measure. So ultimately, if your H will be more means that indenter moves more inside the specimen, means your material will be soft. H will be less, means indenter moves inside the specimen less, means material will be hard. So ultimately, hardness is directly proportional to your H. H will be more, hardness will be inversely proportional to H. Always keep in mind, hardness is inversely proportional to the H. So H will be more, of course hardness will be less. H will be less, of course hardness will be more. So likewise, we can measure hardness of both hard and soft material with the help of Rockwell Hardness Tester. So application, Rockwell Hardness Tester is suitable for both materials, soft and hard material. Means we can check hardness of both materials, soft as well as hard. But always keep in mind, if you have to check the hardness of soft material, use ball indenter. If you have to check the hardness of hard material, use diamond cone indenter. So clear guys? Likewise, our last topic of this chapter is finished, called as hardness testing with the help of Brinell and Rockwell Hardness Tester. And likewise guys, we have finished this basics of engineering materials. So we have to take a review of this chapter, then we can start our new topic in next lecture. So initially friends, in this chapter we have discussed classification of engineering materials. So in classification we have discussed engineering materials are classified into two categories, metals and non-metals. In metals, ferrous, non-ferrous. In non-metals, ceramics, plastic, likewise. Then after that students, we have discussed crystal structure, unit cell, space lattice. After that friends, we have discussed properties of metal, in which physical properties, mechanical properties we have discussed. After that we have discussed what is by sample preparation, different phases of the sample preparation, what is etching process, types of etchant we have discussed in detail. After that, what is microstructure, types of microscope we have discussed, correct na? And generally related to the checking of the microstructure, optical microscope is used, that also we have discussed. After that, hardness testing, pressure on Brinell as well as Rockwell Hardness Tester, that also we have discussed. So friends, likewise, this first unit means basics of engineering materials, we have discussed in detail, in brief. Correct, na? So guys, in next lecture we are going to start our next topic called as non-metallic and advanced materials. In next lecture we are going to start our next topic, non-metallic and advanced materials. So in this chapter we are going to discuss plastics, different types of plastics means polymeric materials. Ceramics we are going to discuss. Then smart materials we are going to discuss. Nano materials we are going to discuss. Clear? So friends, likewise, this first topic is finished, and in next lecture we are going to start our topic called as non-metallic and advanced materials. So okay guys, thank you very much.